Alright, here we go. We're gonna do the homework solutions for problems 3, 5, 7, and 9, section 7.6. So let's start with number 3. Number 3, we want to find the test statistic, p-value, and the critical value. For number 3, the alternative hypothesis, we're told that we'll just put it right here. The alternative hypothesis is sigma is less than 50. The significance level is 0.01 and n is 30. S is 30. So this is our alternative hypothesis. That means that the null hypothesis is sigma is equal to 50. So we're going to start with the we're going to use the var test in our program. It should be loaded onto everybody's calculator. So to get there, we hit program. var test is the program we're going to be using. Hit enter to execute. Test the variance. That is the value of the null hypothesis. Remember, in the null hypothesis, sigma, this is the standard deviation. The calculator is asking for the variance, so we square the standard deviation. 50 squared. That was our null hypothesis. We hit enter, and then the sample size is 30. Hit enter. Sample standard deviation is 30, so the sample variance is 30 squared, and the significance level is 0.01. We hit enter, and we write down the test statistic is 10.44. The test statistic chi-squared is our test statistic, 10.44, and our p-value, our critical values in the left tail, so it's over here, and so that area, we want to choose the smaller value of these two here. So we're going to use 6 times 10 to the negative 4. That'll be this area right here. 6 times 10 to the negative 4. 6.00 times 10 to the negative 4. And then for the critical value, well, let's form our initial conclusion. Our initial conclusion would be to compare this to the significance level, 0.01, and we would, since it's less than the significance level, we would reject the null hypothesis. And well, we didn't need to do that for this problem, so we'll erase that, and we'll also erase this since we don't need the formal conclusion. Lastly, we'll find the critical value. So the critical value, we press math, press up to get to the solver. Should already have this in your calculator. Chi-squared CDF, L, U, D, close the parenthesis, minus A. That's the formula we already entered. And the lower boundary for the chi-squared distribution, that lower boundary is always 0. Starts at 0. The degree of freedom is 1 less than the sample size, so we're going to enter 29. Then the area is the area between 0 and our critical value. So the area is going to be, since our critical value, our critical regions in the left tail, is just going to be the area alpha. Alpha will be the area between 0 and this critical value, which is 0.01. So this area right here, that's all of alpha, that's 0.01. So we go back up to the upper boundary and we solve. So we hit alpha, enter, and we got our critical value is 14.26. Alright, so all done with that one. Let's go on to number 5. Number 5, it says that The significance level we're using is 0.01. We are testing the claim that the peanut M&M candies have a weight that vary more. So sigma varies more than the plain M&Ms, which have a standard deviation of 0.04. 0.04. The sample size is 40. Sample standard deviation is 0.31. Alright, so the opposite of our claim is sigma. We're going to write equals 0.04. This is our null hypothesis, our alternative hypothesis. So we're going to use the var test again. So we hit program. Program. We're going to use the var test program. And the variance that we're testing, the standard deviation is 0.04, so the variance is 0.04 squared. The sample size is 40. The sample variance is 0.31. Sample standard deviation is 0.31, so the sample variance is 0.31 squared. And the significance level is 0.01. So we write down our test statistic: 23, 42, 43. 23, 42, 43. 23, 42, 43 is our chi-squared test statistic. Our critical values are in the right tail, so we're going to choose that smaller value. It's not actually 0, it's very close to 0. So our critical value for this one is over here in this tail. So that will be, instead of 0, the smaller value, we're going to write 1.00 times 10 to the negative 10. That's pretty close to 0. Alright, so now we can compare this to our significance level, 0.01. And as we can see, we're going to reject the null hypothesis because it's less than the significance level. Alright, so now we can write our formal conclusion. There is sufficient evidence to our initial claim represents our alternative hypothesis. So we have support the claim that sigma is greater than 0.04. Lastly is our critical value. So we go back to the equation solver, math, press up to get to the equation solver. Again, the lower boundary should be 0. The degree of freedom for this problem is 1 less than the sample size, which is 39. Alpha is the area between 0 and this critical value right there. This area to the right is 0.01, so that means the area to the left between 0 and that critical value is going to be 0.99. This area between 0 and this value is going to be 0.99. So that's what we're going to enter. Scroll back up to the upper boundary, which is what we're looking for. Hit alpha, enter, and it will calculate this upper boundary, 62.43. Alright, very good. And let's go on to the next problem, number 7. We are using a significance level of 0.05, and we are testing the claim that the new production line has errors with a standard deviation different from 43.7. It's different than 43.7. And then N for this problem is 81 altimeters. The sample standard deviation is 52.3. Alright, so the opposite of our claim is sigma equals 43.7. So this is our alternative hypothesis. This is our null hypothesis. So we're going to use the var test again. Program, var test. Hit enter to execute it. The variance we're testing is 43.7 squared. Since that's the standard deviation, 43.7 squared would be the variance. Sample size is 81. Sample variance would be the sample standard deviation squared, 52.3 squared. The significance level is 0.05. And write down our test statistic, 114.59. And for this one, our critical value is in both tails. So we take this smaller value and multiply it by 2. Take the smaller value and multiply it by 2. That'll give us our p-value. So 0.0068, 0.0068 times 2, and we get 0.0136. 0.0136. Compare that to our significance level, and as you can see, it is less than the significance level, so we reject the null hypothesis. So we can write our formal conclusion. There is sufficient evidence to. Our initial claim is the alternative hypothesis, so we write support. The claim that, restate the original claim. Sigma is different than 43.7. Our critical value, we use the equation solver, math. Press up for the equation solver. Lower boundary is going to be 0. The degree of freedom is 1 less than the sample size, so it's 80. Oops. So this should be 80. And the area under the curve between 0. Now, for this one, the critical value is in both tails. We have a critical region here and here. So we actually we're going to have to do this twice. So this area right here is half of alpha, so that's 0.025. This area here is half of alpha, 0.025. So we'll start with this left critical value. So the area between 0 and this value would be 0.025. And then we're going to go up to the upper boundary, alpha, enter. And that left critical value is going to be 57.15. So chi squared left, 57.15. And then we have a right chi squared critical value. And all we have to do here is change the area under the curve. If the area to the right of this value is 0.025, that means the area to the left between 0 and this value would be 0.975. So we just change the area to 0.975. And go back up to the upper boundary. Hit alpha, enter to solve for that right tail critical value, which is going to be 106.63. Alright, so we're all done with that problem.